page. I will also send it to the organizers. So if you're not on Facebook, you can still have access to the materials. Today's session, we are going to focus on this notion that all learners can learn, and most can learn to a high level. And in terms of content, we are going to be looking at fractions, a topic that sometimes people say students find difficult. But just to let the cat out of the bag, you might be surprised if I say that fraction concepts are not difficult. Yes, students find it difficult, but it's not because they are not capable, because all students are capable. It is not because fraction concepts is difficult. So there is something that is often not realized by many educators as to why this topic is causing difficulties, even though it is not difficult. So that's our focus this afternoon. Two things: the idea that all learners can learn, and most can learn to quite a high level. And then we'll be looking at this topic that is actually not difficult, but why is it causing such difficulties? Let me start with the first. So you have heard earlier in the opening mentioning that Singapore students perform quite well in mathematics. Singapore students perform quite well in education. Today, that has not always been the case. Many of you probably know that Singapore is a relatively young country. We will be celebrating our 60th birthday, so to speak, this year. Singapore became independent in 1965. A fairly new country, you would say. And in the early years, even up to the time I started teaching in the late 80s, early 90s, I started teaching in 1990, 1991. Even up to the point when I started teaching, our students were still not doing very well in mathematics, but in general, not doing well in education. And you probably would know that Singapore wasn't a well-to-do country. It wasn't an affluent country that it is today. Today, people would say that Singapore is an affluent country, but it wasn't the case when I was much younger and when I was a young teacher. So in the case of Singapore, there is a correlation between economic development and education. Many of you probably know the reason why this correlation is so strong for Singapore. Singapore is a country without any natural resources. Yeah, it does not have any form of natural resources. You might be surprised to hear that Singapore buys sand. Have you heard of a country that buys sand? Now you have Singapore. We buy sand from Indonesia and Cambodia, not too far away. So, the transportation cost is not exorbitant. But we need sand to build buildings, which we don't even have. And in fact, we buy water from Malaysia, our nearest neighbor. So many of you do know that Singapore used to be part of Malaysia. But in 1965, it was asked to leave the newly independent Malaysia. So I think we share a bit of history in the sense that we were colonized by the British for a long time. And then Malaysia, together with Singapore, gained independence in the 1950s. And after a few years, Malaysia felt no need to include Singapore and asked Singapore to be independent. And Singapore became independent in 1965. And the government was not able to pay attention to education for quite a long time until the 1980s. So what I'm saying is Singapore students did not do well Let me now give you some sense of the numbers you're looking at the screen now. 500 would suggest that the students are doing okay. 500 would mean they are learning what they're supposed to be learning. You know, the syllabus. They would have learned it. That is the meaning of 500. And a difference of 40 points is equivalent to about 1 year of learning. 40 points, 40 marks is 1 year of learning. This is the most recent findings from the trends in mathematics and science study teams. Earlier, you heard PISA. PISA is for 15-year-olds in science, in mathematics, and in reading for 15 years old students. And TIMS is for grade 4 students, primary 4, as well as grade 8 students, form 2 or secondary 2. So I would like to now alert you to the screen for me to make my first point that all students can learn. In fact, a lot of them learn quite well. Here you see how students, bottom 20% of students perform. So these are the bottom 1/5 students who would struggle in the education system. In any education system, there are students who do very well, but there are also students who would struggle for a range of reasons, whether it is because of home background, whether it is because of issues related to their special needs, or sometimes their personal lives, but for a range of reasons. We always have students who would struggle in school. Here, I would like to show you how an education system's bottom 20% perform. Very often, you would expect them to do not well, but that does not have to be the case. Even though they struggle with whatever they struggle with, it does not mean they cannot learn. As you can see here on the screen, for primary school mathematics, you can see that Singapore's bottom 20%, they do okay. They do more than okay. 500 means they learn what's in the syllabus. So the bottom 20% students, have they learned the syllabus? Yeah, they have learned the syllabus. They are above 500. In fact, they are 1 year above expectation. In other words, they perform better than an average student internationally. The international average for grade 4 is 503, which means the average learners are okay. Around the globe, the average learners are okay, as you would expect it. But Singapore's weaker students outperform the international average by slightly more than a year. And this is not just limited to the younger students. As you can see, the older students are also doing okay, even though they are struggling with school, even though they are the bottom 20% of the system, they are above 500. And again, they're performing better than the average learners around the world. You might also take a note that the average learners around the world is not achieving what is in the syllabus by the time they get to secondary school. I suppose that's why these sessions gave an emphasis to primary schooling. Sometimes they seem to be okay when they're in primary school, but by the time they get to secondary school, they are no longer okay, because the content in primary school, sometimes you can fake it. You can still appear to be learning by learning procedures, by memorizing formulas. But those things will catch up at some point, and we will see that students who were okay when they were in primary school, maybe they were memorizing something, maybe they were just following some formula without much understanding. But by the time they are in secondary school, those who were merely memorizing without understanding, they would have been found to be not doing well. I will now pause a little while, and during this time, you may want to ask question about the first point, which I want to discuss with you, which is the fact that all learners can learn before we go on to fractions. So can I pause here a little while, and the facilitator either will read your question if you're sharing it, or I'm not sure if it's possible for them to also ask question orally. Can I return it back to you?
Yes, I think during the session, people can ask question in text form in the question answer window.
So I invite you to do so. If you have some things that you want to bring up, it's much better to bring up things along the way so we can, be more interactive rather than me just talking at you.
Okay, okay.
Um, One thing I would like to re-emphasize here in the presentation you have done so far, maybe some people may not be able to catch it, that you have been comparing the bottom 20% in Singapore with the average internationally.
That's correct.
So that is something people should appreciate.
So we have now enough data to say that everyone can learn. You see, even the bottom 20%, they can get 500. In fact, more than 500. And outperforming average learners around the world. And this 4 session is for us to know how this can happen. There is no magic. Yeah, there are systematic ways. Some can be done by us teachers in a classroom. Some are under the responsibility of the leaders, whether it's a school leader, the headmasters, the principals, or even the Ministry of Education. I will focus quite a lot on what the teachers in a classroom can do. But depending on what you want to know, I can tell you anything really. So there's no secret really. There are research based, theory driven techniques that will allow this to happen anywhere on earth, not just in Singapore. So sometimes I tell people that there's really no such thing as Singapore math or Singapore maths. I often start my presentation by saying there's really no such thing because in Singapore, we just call it maths. So if you have something you would like to bring up, either a sharing a point or raising a question about this idea of any child, every child can learn. In fact, even the weaker students can learn at a high level. If you're 1 year above average, you'll be considered quite advanced in most countries. So our bottom 20% would have been advanced students in many countries. Questions?
Yes, there is one hand raise. I'm going to take that question. Ahmed Hussain Saab, if you have any question or if you have some points, you can come up. Your mic is open. Okay, Aisha Babar, your hand is raised. If you have any question, please ask. You can ask. Aisha Babar, you can ask question if you have any question.
Sir, can you listen me?
Yes, I
Yes,
can hear you.
Okay. Your voice was not clear and I didn't get your point. I just want to say that please make it possible to listen. Thank you.
Are you able to hear me clearly?
Yes, now your voice is clear, but when you was addressing, when you were delivering the lecture, I didn't get any point to what you said.
All right. Is that a common problem? I hope it's not. I hope the rest of you are able to hear the
Your
audio
voice was
clearly.
much distortion. There was much distortion.
Okay.
Okay, okay, please. Actually, they may have some internet issue on one side. So if you have faced any problem, you can check the recording as well. The session is recorded as well. So
Okay, sir.
if
Thank you.
okay, okay, thank you. Yes, Mr. Ben, I think you should go ahead.
Yes. So I will say a little bit more before I move on to fraction. So here I just share with you an earlier year results. The one I showed you earlier was the most recent one from 2023. The result came out in 2024. But a previous cycle of the study from 2020 to 2019 show a similar findings. And on this table, you see how a few education systems are helping their students in mathematics. So the first point I want to make is that every student can learn. So earlier I show you that even the bottom 20% of the cohort can learn what is in the syllabus and they perform 1 year above international average. So that data is to support the point that even the weakest student in a system can perform at a rather advanced level. Students who are 1 year above expectation is often considered quite advanced in most countries. But in places like Singapore, you can find these students even among the bottom 20%. So the first point I want to make is that it is not just a hope, it is not just a vision, it is already a reality in several education systems. Singapore is one of them, where the idea that all students can learn mathematics has been shown with empirical data. I will end this segment by summarizing the three things that can cause low performance in mathematics. So when we were trying to find out what is causing the low performance of Singapore students in the 60s, in the 70s, in the 1980s, we found out three things that cause low performance. The first one is memorizing. Rote memorization is one of the three reasons. Our students were asked to memorize quite a lot of things back in the days. The second reason is overemphasis on procedures. Not that procedures is wrong, but procedures without understanding. So our students were taught steps, procedures, how to divide a fraction by a fraction, for example, long division procedures. And they, if they are obedient, they can carry out the procedures, but they have little understanding of what they do. And even though they appear successful at one point, that will catch up with them. It could be as early as secondary school. That's a second reason that caused low performance. Finally, overemphasis on computation, overemphasis on technical work, compromising thinking. We all know that a lot of technical work is now taken over by technology with artificial intelligence and all the things that's in the news these days, from ChatGPT to DeepSeek. We all know that mundane work is not so important these days. But thinking, continue to be the domain of the human minds. An overemphasis on mundane, tedious work, overthinking, is a third reason causing low performance in mathematics. So if you do not want students to not do well, then we have to avoid these three things. The Singapore system have over the years tried to dismantle these three aspects. You know, things are never perfect anywhere. So even in Singapore, although things are much better than before, I can tell you, coming from the system, it is still work in progress. But things have become a lot better since the 1980s. This table I'm showing you here give you a very good control group. On this table, you can see the performance of two countries that used to be the same country having practically the same system until they went the separate ways. Culturally, these two countries continue to be very similar. You cannot tell the accent of a Singapore person from a Malaysia person. We share the same culture, we have the same foods. Not surprisingly, they used to be the same country. But you can see the performance have now become quite different. They used to be the same, even as recent as the 1980s. In the 1980s, Singapore's performance were about the same as Malaysia's performance, which is averaging about 450, which means our average learners were behind. Not a good situation, obviously. Behind by one school year. Remember, 500 means okay, and 40 marks means 1 year. So our average performance was around the same as Malaysia's, about 40 points, 40 marks below expectation. But these days, it is quite different. But what is more important is the performance of the bottom group. Singapore's bottom 10% is quite close to 500. This is the older data. The more recent data have shown slight improvement. But Malaysia's bottom 10% continue to be many years below expectation. But many people often do not pay attention to that. Many people will say, what do you expect? These are weak students. And they will shrug their shoulders and say, what do you expect? These are weak students. Do you mean you expect them to do well? The answer is yes. They can do well. They can learn what's in the syllabus. And the most recent finding tell us that not only can they do the syllabus, they can exceed the syllabus by sometimes up to 1 year. All right. So I'll conclude the first segment and then now move on to the second segment where I talk about fraction. But before I talk about fraction, I would like to give you another chance to bring up questions. Do ask questions because that's what you do with your students as well. You want your students to bring up questions. And you can ask questions either related to what I just talked about, the first point, or you can share with us what common difficulties your students have in learning fractions. So I'll give you a couple of minutes for you to raise question either in a chat box or just bring it up orally. At the same time, I want to make sure that everyone is hearing my audio loud and clear. Is the audio okay still?
Yes, audio is okay, 100% okay. And Shahnaz Iqbal, you have raised the hand to ask question. If you have any question, please go ahead. Shahnaz Iqbal. Yes, please. Shahnaz, if you have any question, please. Okay, I think you should proceed.
All right. So let us move on to the second part of this session, looking at fractions. So many educators around the world say that fraction is a difficult area for their students. I wonder if that's the case also in Pakistan. Would many people say that fraction is a difficult area of learning for students? I wonder what those difficulties are. If you're able to share them in a chat room throughout the session, our facilitator will bring it up and then I'll address your questions directly. For example, a rather classic mistake you sometimes see students make in a calculation you see on the screen. The screen is clear to you?
Yes, it's clear.
I'm sure many teachers would tell us that some students do this, which of course is incorrect. And you'll be so surprised why students make this mistake actually, because it's totally illogical how 1/4, you know, 1/4 is quite a lot, and 1/3, which is even more than 1/4, how this can be total up to something less than half. Because a student with some understanding of fraction will know that 2/7 is less than half. So it's a mistake that is almost impossible to make. But yet, many students around the world, based on research on fraction, have been found to have this common error where they add up numerators and they add up denominator. Many people say fraction is difficult. Is it really difficult? Let us analyze what is involved in fraction. Let us now just think as an adult. Many of you are teachers. What are the concepts involved in fraction? And then let's decide whether those concepts are so difficult. Because if they are, we must take great care in unfolding them to students. Or if they are not, then why is it causing such a difficulty? First idea in fraction. Some things you can cut up, some things you cannot. Some things you can cut up, like a cake. A cake you can cut into pieces. A cake you can cut into parts. A piece of paper you can cut up. A piece of paper you can cut up into pieces, into parts, whether equal in size or not. It doesn't matter, but you can cut them up. So some things you can cut them up. Don't have to bother students with technical words, but we call this continuous quantities. So continuous quantities, they exist in fractional parts. You cut a cake up, you can get half a cake. You cut a pizza up, you can get 1/4 of a pizza. You pour out some water, you can get half of whatever you have in the bottle. You have some amount of money, you can get 1/3 of the amount. So some quantities are continuous in a sense that a fraction of it makes sense. But some things, not really. Some things, like a drinking glass, I know you have machines these days that you can use to slice glasses into pieces. Or you can just crash it. You can just use a hammer to break it. You can just drop it on the floor. You'll get into many hundred pieces. But when those quantities are broken, are cut up, you don't get a fraction. You still get one glass. Just that now, the adjective change. You get one broken glass. Even though you cut it up into two, even though you break it up into 100 pieces, you don't get one half, you don't get 1/100th. You don't have things like this. You still get one. Just that the adjective will change. Whereas for things like paper, when you cut it up into pieces, you do get fractions, like 1/4 of the paper, 1/2 of the paper. You do. But for quantities which are not continuous, we call them discrete. Yeah, my spelling is wrong. Do you know there's two words that's discrete? And one of the discrete is the mathematical discrete. Yeah, for discrete quantities, you don't get half a glass. You get one broken glass. You don't get 1/10 glass. You don't get 1/100th glass, right? So is this idea difficult? Is the idea that some things can be cut up and some things cannot? Is that really a difficult idea? Because if anything is difficult, then as teachers, we need to find ways, and this course is about finding ways to make it accessible to students. More importantly, I am wondering whether, as teachers teaching fractions, do our students know that some things exist as fractions? And some things don't. I'm not sure about Pakistan. In some countries, you're not allowed to cut up your banknote. I think most countries are not allowed to, but in some countries it's actually illegal. Like in Singapore, if you do that, it's illegal. You can be fined or you can be charged for destroying a banknote. Not that I know of anyone who would destroy a banknote, but if someone is crazy enough to cut a banknote into two, you don't get half a dollar. You get one invalid banknote. Yeah? So some things don't exist in fraction. Likewise, the example I gave you earlier, you break the glass, you break the cup, you get one broken glass, you get one broken cup. You don't get half a cup, you don't get 1/10 of a cup, you just get one broken cup. So this is one important idea in fraction. I have the same two questions for teachers throughout today. Is this really difficult? Whenever the answer is yes, it is difficult, we'll then need answers from the next few sessions. The next few sessions will focus on, if something is difficult, what do we do? Our job, that's why they call us professional teachers. And like all professions, we have our tools. Like engineers, they have their tools. Surgeons, they have their tools. Doctors, they have theirs. Pilot, they have theirs. Likewise, we teachers, we have ours. Our job is not just always trying our best. Can you imagine an engineer say, we're building a bridge? Let me try my best. Can you imagine a surgeon performing a knee surgery and she say, I'll try my best? Can you imagine a pilot taking a plane off and say, we'll try our best? They don't. Very often, their outcome is positive. There's a very low percentage of unsuccessful bridge building, unsuccessful knee operation, unsuccessful takeoff. There are, but the percentage is so small. Likewise, as teachers, we will always have a small percentage of students who cannot learn the syllabus, but it should not be a significant number. Otherwise, it'll be like pilots making so many mistakes taking off, causing crash upon takeoff. Likewise, knee surgeons having such a high percentage of patients who cannot walk after the surgery, and high number of bridges around the world collapsing on regular basis. We don't hear those. Likewise, in education, we shouldn't be hearing students failing routinely. It should not be. The next 3 sessions, we're going to focus on whenever we have the answer as no, this is not easy. Because if it is easy, the students will learn it quite naturally, I would say. In other words, they do not need special help in learning it. So I'm asking you the question, is this idea difficult or not? If it is yes, we'll find answers to them, how to make it accessible. And if the answer is no, then we kind of know that all we need is to expose them to the idea. Mere exposure is good enough for them to realize that, oh, distance, a cake, a pizza, a piece of paper, I can cut into pieces. But a banknote, I'm not supposed to. A glass, a drinking glass, a cup, I hope I don't break them. Because if I break them, I will get 1 broken cup. I don't get 1/100th cup, right? I'll pause here a little while. I've just shared with you the first idea in fraction. There are only a few. Every single topic in mathematics, there are only a few essential ideas associated with the topic. So learning mathematics should not be overwhelming, because fraction, there are only 2 big ideas. When students learn 2 big ideas, that's it. So as teachers, we need to know what those 2 big ideas are. I'm in the process of unfolding the first big idea, which start off with this sub-idea. Things, some exist in parts, some don't exist in parts. I'll stop here. Again, an audio check. Is the sound still okay? And more importantly, dear colleagues, if you have questions, if you have points that you want to share, you want to bring up, questions you want to raise, you should do it, yeah? And then I will be able to share with you the next point following your questions.
Okay. Actually, we are a little slow at asking questions. I hope that when we are a little bit ahead, I hope that few people may ask questions. Okay, about fraction, we have a session before with these attendees. So one of the very question by a teacher that she was very curious about how we can teach the fractions. Students cannot understand fraction in a simple way. And especially I want to tell you about what we practice at most in Pakistan, that we are very much interested in this, that half, like 1/2 plus 1/3, what should be the technique to solve this abstract math, that 1/2 plus 1/3 and will give us that some answer.
Okay.
So we are actually, if we say that most of the time we are very much interested that we have to tell them in an abstract way. But this way that you are telling, that the fraction student have some idea that what is actually the fraction. So it's the story behind that abstract math. So
Yes. Yeah, maybe I'll elaborate on what you just brought up. It's connected to my next point.
Yes.
So it's very important that when students learn anything, they always start with the concrete. No exception. So no teachers would go into class and say, boys and girls, today we are going to learn how to add 1/2 and 1/3. That will violate Bruner's theory.
Hmm.
So remember, I say that our subsequent session is learning the tools. This is one of the tools. Whenever students have difficulties, we have a few things that will tell us how to help them overcome the difficulty. And one of it is Bruner's theory. Jerome Bruner in 1960s gave us a very important answer, because many teachers have the same question that you do. Oh, it's too abstract. It's too abstract. Bruner say, give them something concrete. For fraction, the concrete thing is easily available. Pieces of paper. Just paper. The paper can be used to represent fractions, because paper can be easily cut into pieces, can be cut into parts. A piece of paper representing 1, and you can cut the paper in quite many ways, because paper, as we all know it, foldable, easily cut up. So it's quite easy for students to see concretely what is 1/4, what is 1/3, what is 1/2. In fact, any amount that we need them to see. Of course, we can also say, let the paper represent a cake. I have a cake. Let's use this paper to represent the cake. And later, let this paper represent an amount of money. I have some money. I don't know how much it is, but let us use this paper strip. The paper can be any shape, really. I think rectangle and square are easy to work with. Let this represent the amount of money that I have. I wonder how much that is, but this is an amount of money. Yeah. So Bruner gave us this very clear answer. If anything is too abstract for our learners, how do we get them there? How do we make sure the abstract is accessible to all learners? Bruner's answer, don't start with abstract. Start with concrete in order for them to get to the abstract. And in between, emphasize a lot on pictorial representation. This term, CPA approach, is something we tell our teachers in Singapore. All our teachers will know what is a CPA approach. Singapore is not a big country, so it's not difficult for us to tell everyone, whatever we want to tell them. But actually, it's not a matter of number. Despite the number of surgeons we have around the world, they all learn the same thing, isn't it? Despite the large number of pilots we have around the world, they all have the same knowledge. I think education is quite a special field. Somehow, teachers around the world don't all learn the same thing. I suppose that's where we need to look into ourselves in order for people to see us as professional. We all must have the same set of knowledge that works. That's why pilots, they all have the same training. Yeah. Surgeons, they all use more or less the same procedures when they do a certain thing. Of course, they got a few options, but they all kind of know all the options. Likewise, as teachers. So the size of a system is a problem for education. So I go to small countries like Singapore, the teachers all know the same thing. But it's not always the case. Recently, I went to an even smaller country with just 200,000 people. but the teachers don't all learn the same thing. So I think the size of the population is not a factor. Previously, many people say, oh, big countries, very hard to get all the teachers to know the same thing. But then you think back about pilots and surgeons around the world. They don't have the same problem that we have. Yeah. So I'm really glad of this initiative that we are starting. How we try to start with a group of people like you who are really motivated to make a difference to the learning of your students. Yeah. So whenever you have the question, this is too abstract for my students. Listen to Bruna. Bruna has told us a way out. Make it concrete, make it pictorial. That will make it accessible. Right? I'll pause here. I've not answered your question fully, but I'll pause here in case someone else wants to bring up something. I'll be happy to deal with it.
Yes, that's great. Understandable. As far as I explore that Singapore, that term is very common, concrete, pictorial, and abstract. But we are very unaware of these type of terms and these methods. So actually, we have to look into it, and we will because in Pakistan we have most of the time we are dealing with abstract, and few of the question in the question answer sections by the esteemed teachers is that we are how can we teach fraction in a more easy way.
Yes.
So actually their questions are from the abstract portion.
Yes.
So
I'll get to that in a short while. Whenever we teach fraction abstractly right from the beginning, students who benefit are this group of students. Like the 6 students who represent a country in IMO, you actually don't need to worry about them. I'm sure you don't have to. Yeah. I think the top 10% of any education system are always more than okay. Never mind the system. Even in system like Southeast Asian countries, Malaysia is a typical system in Southeast Asia. You go to Thailand, Indonesia, you will see something quite similar. Sometimes a little bit worse than this. But in Southeast Asia, even though we are not doing very well, even for average learners, the high achieving learners are always okay. The high achieving learners, they actually don't need schools. They will do well, even if they don't come to school. In fact, someone has speculated that school has slowed them down. But it's just a speculation. There's nothing concrete really from research. But a lot of people say that schooling interfere with education. So we don't really worry too much about the high achieving students. They probably have reached the level of abstraction already. In other words, they don't need a CPA. But we are talking about the bottom group, the average learners. How do we get average learners to do really well? 628 is 128 marks above 500. 500 means they are okay. 40 marks is 1 year. An average learner who are 3 years above expectation. This is it. They are average learners, but they are 3 years above. They are really advanced. How do you get average learners to be so advanced? There's no secret. Bruna, among others, there are only 5 actually. Bruna gave us one of the 5 answers. So the 4th session is essentially allowing us to answer the question, how do we get average learners to perform at a very high level? You got the first answer already. Don't go to abstract. You go to abstract, you'll benefit this group who are already okay anyway. You can tell. They'll be okay anywhere. Bruner's idea is to help this group, the average learners, perform at a spectacular spectacularly high level. Average learners, the 50th percentile, the median, performing at 3 years above expectation. And also, quite importantly, struggling learners, they are not left out at all. If we want those outcomes, then Brunner is one answer. Coming back to fraction. How do we make the abstract accessible? So concrete, all that is fine. Yeah? But how do we make the abstract accessible? So let's go back to the two important things in fraction. Fraction, there are only two important things. Make sure students know these two things very well. The second one, I think they know it well. So I don't have to spend very much time. But the first one, despite its simplicity, research have shown that it has been left out in many education systems. We're in the process of the first idea. The first idea so far seems quite easy, isn't it? Yes, it is easy. Research of classrooms around the world have surfaced that this first idea is not well known to students. What is a first idea? This is the first idea. Some things exist in fraction. Now, when you have a piece of cake, when you have a cake, you cut it up. You have a piece of paper, you cut it up. You can get parts. And the parts, they all have a name. I think most people know that. They have names like half. They have names like quarters or fourth. They have names like thirds. They have names like sixths, and so on. They all have names. That is why they are called denominator, from the word denomination. Denomination is just a big word for name. Yeah? What's the denomination of the coin? What's the name of the coin? So in US, they name their coins. It's a dime. It's a penny. In Old English, it's a shilling. Or in Singapore, we are quite pragmatic. We just say we call it as it is. It's a 20-cent coin. Yeah. So it has a name. Yeah, it has a name. In some countries, the names are more names. In other countries, it's more literal. 50-cent coin. That's a name, isn't it? Anyway, we all know the word denominator suggests that it is a name. Right? And the name depends on how big the piece is. If the piece is 4 of it, make the whole thing. So this one, how do we decide on the name? It depends on how many of this you need to make one. If you need 4 to make one, then that's the name, quarter. If you need 10 pieces to make one, the name is tenth. If you need 6 pieces to make one, the name is sixth, and so on. So that's the nomenclature. That is a system. That is what Richard Scamp, called convention. That is a convention. Convention means system. Convention is just like the way we do things, right? Like in some countries, the ladies will wear a headgear. It's a convention. In some countries, the men wear sarong, like in Myanmar. It's a convention. In some countries, people wear tie. The men wear ties. In some countries, we don't. In some countries, we leave our footwear at the door. In some countries, they wear footwear in the house. Yeah, in some countries, they put their hands together to say hello. In other countries, they shake hands. Convention. Yeah, in some countries, this would mean a big number. In some countries, this is a number less than 2. Yeah, so the comma is used differently. In European countries, they use it as a decimal point. I think in Pakistan, because you use a British system, a decimal point will look like this. But the European system, they use a comma. Nobody is right, nobody is wrong. It's just different convention. Right. Anyway, for fraction, this is a convention for the name. How do we determine the name? It depends on how many of it make one. If you need seven pieces to make one, then the name is seventh. And from there, that's basically it. If you're interested in 3 pieces, then you just say accordingly. Well, I have just shaded 3/4. 3 pieces, the name of the pieces, quarter. And following the grammar of English, quarters. 3/4. 3/4. And that is what we call a fraction. 3/4. So that is the first important idea in fraction. Some things can be cut up, like paper, like cake. And the pieces, the parts, they all have a name. And the name follow a system. How many make one will tell you the name. Oh, but wait a minute. It is the convention. We don't spell the word quarter out normally. We use a symbol for it. That is a symbol for quarter. It is exactly the same thing. Why? No reason. It's a convention. Why don't we write it the way we write things normally? I mean, normally, you will say 3 cats. You will say 3 boys. You will say 3 pieces. You will say 3 apples. You will write the number in front of the word. You write the number in front of the name, the noun. That's what we do in English anyway. That's what we do. That is what people have come to expect in English language. 3 boys, 3 watermelons, 3 girls, 3 oranges. We expect number plus noun. We expect a number followed by a noun. And we expect the noun to be in words. But not so for fraction. In fraction, yes, you have the number. Yes, you have the noun. But the noun is a troublemaker. The noun is a troublemaker because it's not written out in words like we expect it to. It is written like so. Many students do not know that this is 3 something. 3/4, 3 pieces, 3 slices, 3 parts, 3/4. And in many countries, especially those like ours, Singapore, just like Pakistan, I'm sure, English is not the first language for our students.
Yeah.
In many places where English is not the native language, we often say some words wrongly. We have our local way of saying it. For example, we have a big problem in Singapore with this. In Singapore, we call it Singlish. It's a form of English nobody else will understand, only us in Singapore. In Singlish, We don't say 3/4. We say 3/4. It's not proper English. It's not a standard English. But we say it all the time. Of course, we shouldn't say it in class. But sometimes, we forget. Teachers, sometimes we forget. We use our local language in class. And we say 3/4. I suppose it's okay once in a while. But sometimes we say all the time. And then students also say 3/4. The moment they say 3/4, they have lost the meaning. Because nobody say 3 upon a cat. You say 3 cats. You don't say 3 upon a piece. You say 3 pieces. You don't say 3 out of boys. You say 3 boys. Yeah. So the moment we say it improperly, the conceptual meaning is lost. So everything students know about 3 apples, 3 boys, 3 cats, 3 pieces can no longer be used for 3/4. We all know language is so critical in thinking. Yeah. So actually, 1 and 1 is not difficult. Everybody knows it's 2. But wait a minute. Are you sure it's always 2? We all know it's not true. This is not 2. Anyone knows this is not 2, right? We only know it's 2 if both the nouns are the same. Well, in this case, it's 2 ones. We know that it's really not a very difficult concept. It's only 2 apples if both are apples. We all know that. I think any child knows that. But if this is not the case, well, I think any child knows this. You cannot add 1 and 1 if the nouns are different. 1 orange and 1 apple is never 2 apples. It's never 2 oranges. Of course, it's never 2 watermelons. You just simply cannot do 1 orange and 1 apple. Unless, of course, you can change a noun, which we can in this case, quite easily. Pieces of fruit. Yeah, pieces of fruit. So likewise, 1 boy and 1 girl, we all know. When you count a boy and you count a girl, you don't get 2 boys. It would be a disaster if you do. You don't get 2 girls. You don't get 2 cats. You don't. Yeah. You cannot do 1 boy and 1 girl. Oh, of course you can if you change a noun. 1 child and another child. Well, business as usual. 2 children. Yeah. So, yeah, the problem that you raised a while ago, again, I ask you the same question. Is it really difficult? Well, it is difficult because many students do not know that this. It is difficult because many students do not know that these are half and third. When they see what they see, they do not realize that the denominator, the parts in blue, is the name. It looks like it is a number, but it's not number in a counting sense. We all know numbers can be used for counting, but numbers can also be used for names. R2D2, yeah. Or you take a flight SQ321. These are just names. It's not counting numbers, right? Flight numbers, yeah. Your telephone number, yeah. Your cell phone number, your mobile phone number. You cannot say, oh, let's add up my phone number with my spouse phone number. It doesn't make sense. It's not a counting number, so you don't add it up, yeah. But why are they adding this up, right? You don't add up phone numbers. You don't add up bus numbers. You don't add up flight numbers. But why are they adding up denominators? It's simply because they don't know that these are denominators. Yeah, I know they will say these are denominators, but they don't know the meaning of saying these are denominators. They do not know that saying these are denominators means these are names. These are names like Ali and Amir and Banha. These are names. So happen to look numerical, but they are names like R2D2, like names of flights, like names of cell phone number, cell phone line. Yeah? So again, I want to ask you, is fraction difficult? By the way, I've just given you the complete first idea. The complete first idea is how to read. How to read this. Can they read this? If they can, when you ask them, how many pieces? They will tell you 3. If you ask them, what are the names of the pieces? They will tell you 5th. If you ask them, what's the meaning of 5th? They can tell you it means 5 pieces will make 1. If they can say all that, they got the first idea. The second idea is equivalent fraction. Fraction has only 2 important ideas. Every single topic in mathematics, there are only 2 important ideas. Why some students cannot learn it is because those 2 ideas are not well understood. Sometimes it's because the concept is difficult. Then the other 3 sessions in future will give us answers to how to make it accessible. But if the answer is it is not difficult, we then have to question ourselves. Why? Yeah, why? Why is it so difficult then? Because why is it so difficult? Because when you ask a very small child, say, please go to the basket of fruits, go to the basket of 4 bananas, please get me 1 apple. When you say that to a very young child who have not gone to school, the child will giggle. I can guarantee you that. Just point to the basket of 4 bananas and say, please get me an apple. They will giggle, they'll find so amusing. Why this adult is so ridiculous? What I'm saying is that this concept is not difficult. Even a young child knows that you cannot operate, you cannot add, you cannot subtract. You cannot do these 2 operations. You cannot. When the nouns are different. These are essentially the same thing. You just cannot. You simply cannot subtract 1 from 4. You cannot just yet. Yeah? And the second idea is, well, if the nouns are different, make them the same. So I suppose in this case, there's an easy way out because it's quite easy to get 4/5 to become 8/10. So now that this is 8/10, business as usual. Now that they're all tens, well, subtracting 1, 1/10, subtracting 1 from 8, well, that's not really a problem. And students will just know the answer. Only 2 important things in fractions. Knowing how to read the symbol and then being good at equivalent fraction. I'll pause here. We got a bit of time for you to ask whatever you want to ask. Play the devil's advocate. You can say, oh, but what about this? What about that? And then I will answer your questions. Back to you.
Yes, I'm going to take the questions. Yes, ma'am, Atka, you can ask question. Regarding this session or this discussion, if you have any technical issue, you can ask the technical team which are dealing on mobile phone. If you have any issue regarding this question from this session, Yes, ma'am, Atka. जी, if you have any question, अगर आपका क्वेश्चन उर्दू में है, उर्दू में बता दें, हम इसको ट्रांसलेट कर देते हैं। सब लोग अगर कोई क्वेश्चन करना चाहता है तो उर्दू में भी कर ले, हम उसको ट्रांसलेट कर लेते हैं।
Yeah, you can ask in any language. There'll be a translation.
Yes.
I believe today's
Ji, yes.
teachers, there are many of them teaching fractions. Is that right? Like primary 5, grade 5?
Yeah, primary 5 teachers. Yes, मोहम्मद इसाक साहब, सर, आप कुछ क्वेश्चन करना चाहेंगे?
बिस्मिल्लाहिर्रहमानिर्रहीम। जी, थैंक यू सफीउल्लाह साहब। मैं सिर्फ ये चाहूँगा कि थोड़ा सा आपने खैर कह ही दिया उर्दू में एक्सप्लेन करने के लिए या उर्दू में क्वेश्चन करने के लिए, क्योंकि ये मुश्किल हो सकती है हमारे रिस्पेक्टेड टीचर्स के लिए कि वो अंग्रेज़ी में, ज़ाहिर है कि हमारी फ़र्स्ट लैंग्वेज ये नहीं है, ख़ुद डॉक्टर बेनहर ने भी यही बात कही है, तो हम
सही है सर।
इसको थोड़ा सा इजी कर सकते हैं। और मज़ीद जैसे उन्होंने डिनोमिनेटर्स के बारे में कहा, तो वो भी थोड़ा सा आप मुख्तसर सा आप अगर एक्सप्लेन इनको कर दें कि वो डिनोमिनेटर्स नेम के लिए हम इस्तेमाल कर रहे हैं।
जी जी, मैं बता दूँ।
जी, थोड़ा सा बता देंगे तो थोड़ा सा टीचर्स के लिए, हमारे रिस्पेक्टेड टीचर्स जो है वो एक आसानी के लिए हम ज़रा ये कर ले प्लीज़।
जी, सुमेरा अशफाक, अगर आपका कोई क्वेश्चन है तो बता दें। मिस सुमेरा अशफाक। Okay, ji. I think Dr. Ben, no more questions, but let me explain a little for just 1 minute in Urdu what we are discussing here.
Yes, please.
जी, टीचर्स, अभी जो हमारी डिस्कशन है, आप लोगों के कुछ क्वेश्चंस भी इस बारे में हमारे पास आए थे कि फ्रैक्शंस के बारे में कुछ टीचर्स ने पूछा, और लास्ट सेशन में भी ये बात हो रही थी कि हम कैसे बात कर रहे हैं, और अभी कुछ लोग बता रहे हैं कि हम एलसीएम्स ले रहे हैं या उसको फाइंड आउट करें, जैसे कि इन्होंने इस सेशन को स्टार्ट किया है। और सेशन के स्टार्ट में इन्होंने बताया कि हमें ये नहीं देखना कि हम जो उसका 1/2 या 1/3 है हमारे पास, उसको जब हम ऐड कर रहे हैं तो कैसे कर रहे हैं। बच्चा उसको कैसे देख रहा होता है कि 1 को 1 में ऐड कर देगा और 2 को 3 में ऐड कर देगा और उसको 1/5 लिख देगा। तो अब हमें जो उसका जो कंक्रीट बैक है, देखें ये टेक्निक सिंगापुर में बहुत ज़्यादा यूज़ होती है, कंक्रीट, पिक्टोरियल एंड एब्स्ट्रैक्ट। कि कंक्रीट बैक में अगर हम देखें कि हाफ है, 1/2 इज़ हाफ, कि अगर कोई चीज़ हाफ है और 1/3 इज़ थर्ड पोर्शन ऑफ समथिंग, किसी चीज़ का तीसरा हिस्सा है, तो अगर इन दोनों को ऐड करें तो ये कभी भी 5 में से 5 में से नहीं होने जा रहे। लेकिन चूंकि वो इस तरह हम सोचते, कंक्रीट में जाकर सोचते नहीं है, जो रियल में एक्चुअली फ्रैक्शन है उसको हम इस तरह नहीं देखते, तो सिर्फ हम उसका जो नंबर्स हैं उनको हम डील कर रहे होते हैं, या बच्चा भी उस एब्स्ट्रैक्ट को डील कर रहा होता है। और हमारा ज़्यादातर क्लास में फोकस भी यही होता है कि एब्स्ट्रैक्ट के अंदर हम चल रहे होते हैं कि अगर 1 ऐसे लिखा हो और 1/2 लिखा हो और फिर 1/3 लिखा हो, तो आपने एलसीएम लेना है, और एलसीएम लेने के बाद आपने उसको ऐड कर देना है और वो हाँ ऐड हो जाएगा। लेकिन एक्चुअली हमें उसकी कंक्रीट वैल्यूज़ पर जाना चाहिए कि ये एक्चुअली है क्या। तो ये डॉक्टर बेन जो है ना, वो फ्रैक्शंस के बारे में डिटेल में बता रहे थे कि हम जब कंक्रीट उसको किसी पीस ऑफ पेपर के फॉर्म में बताएंगे, अगर हमारे पास पीस ऑफ पेपर है और वो 1/2, उसका मतलब हाफ ऑफ द पेपर और एक 1/3 ऑफ द पेपर, उन दोनों को इकट्ठा करेंगे तो हमें पता लगेगा कि ये तो इतना तो कम से कम नहीं है कि वो पहले से भी काम हो जाए। तो हमें ये इस तरह देखना होगा कि कंक्रीट में चीज़ें कैसे चल रही हैं। और ये बार बार वो वर्ड यूज़ कर रहे हैं, CPA, कंक्रीट, पिक्टोरियल एंड एब्स्ट्रैक्ट। ये एक वेल नोन रिसर्च है बाय, आई थिंक, आई डोंट रिमेंबर द नेम दैट,
Brunner.
ब्रूनर। यस दैट ब्रूनर जो कि उन्होंने एक ये टर्म इंट्रोड्यूस करवाई कि इस तरह हम बंदों को जो है वो समझा सकते हैं ये सारी चीज़ें। अच्छा, आप इस और भी देखते जाएं और काइंडली आप इस सेशन में क्वेश्चन करें ताकि जो हमारे मेहमान हैं वो भी ये ना सोचें कि टीचर्स के पास कोई क्वेश्चन ही नहीं है। सो प्लीज़ आपके इस रेलेवेंट जितने भी क्वेश्चंस हैं उनको ज़रूर रेज करें और हम इन क्वेश्चंस को आगे एड्रेस करेंगे। ओके डॉक्टर बेन, यू कैन नो स्टार्ट. I have requested the teachers, esteemed teachers, that they should ask questions, and I hope they will ask question next onward. So I think you should continue with from no, then we will ask questions.
Yeah. So far these are the things that is important in fraction. Yeah. So do you know the two important ideas in fraction? The first one is they know how to read the symbol. They must know how to say 1/2, 7/10, 3/5.
Yes, that's
Which
correct.
means when they see the symbol, numerator is 7, they must know that means 7 pieces. And then they see the denominator, they must know, that's the name. So when they see the denominator is 9, they'll say, that's the name, ninth. That means 9 of that will make one whole thing. So that's the first conceptual understanding. That's the first understanding they must have. And the second one is they must be good in equivalent fractions. Because equivalent fraction allow them to change the name quickly. Like 1/3 is 2/6. So when they need 6, they can easily get it. So these are the only two important things. And I demonstrated using example of addition and subtraction. So the rest of the time, we got about half an hour. Do ask question. You can also play the devil's advocate. But what about this operation? You have taught us about adding, subtracting, but what about this? So when you ask those, I can show you, you will still be doing the same two things. So this session is to tell you in a nutshell, if your students are struggling with fraction, what must they focus on? I do not know about the situation that you face because I've not been to your country or your classroom, but based on research around the world, I suspect it's not different in Pakistan. The difficulty is the first one. Many students do not know how to read the symbol, meaning they do not know the numerator is the number and the denominator is just the name. Yeah. Most places, equivalent fraction is not a big difficulty, or at least it is taught. What is missing is often the first one. Yeah. So maybe there are some questions already that come up. I will be happy to continue from there.
Dr. Ben, have you shared your screen or something?
I have stopped sharing screen for
Okay,
now.
okay.
Yeah.
Okay.
So you can see me.
Okay.
It's a bit weird that you hear my voice and without seeing my face the whole time. I'll try to fix this thing so next session you can see both at the same time.
Yes.
Any particular thing about fraction that you want me to use for the last segment? So the last segment is really a question and answer segment
Yes.
for you to ask whatever you want. Yeah. And
Yes,
I'll be
Mr.
happy.
Rashid. Mr. Rashid Yamin. You have raised your hand to ask question.
Assalamualaikum.
Ji,
Sir,
walaikum
my
salam.
question is that kindly explain the decimal fractions as like simple fraction. What is the meaning of whole part and the decimal part? Kindly explain it.
So if can I just check that the question is asking me to explain about decimal fraction? Yeah. Is that right?
Yes, he actually want to relate decimals and fractions and
Yes. Yes.
etc.
So I will
Thank you,
share
sir.
my screen now.
Yes, you can.
You can see my screen and you can hear me.
Yes.
Thank you. So thank you for that question. Asking about decimal fraction. Yeah. So we all know decimal fraction is a fraction. Decimal is just an adjective, right? A kind of fraction. Yeah. So decimal fraction, they have special names. We all know that. So these are all the decimal fraction students typically learn. I don't think we bother them with, anything smaller than that, but these are the ones that we typically teach students. Of course, you can go on, and do any number you like, but I don't think students need to know such small, tiny amounts. So we don't usually bother them with those. But so the answer is quite easy then. It's exactly the same, right? It's exactly the same. But let me elaborate now. So yeah, decimal fractions can be anything, right? Now, when we do common fractions, the name, we write it down, isn't it? You see, the name, we write it down. We write down the names. But we have a different number system. In another number system, like this number 3/10, we write it like so. We don't write it like this. In this system, the name, we can see it. How many? We know it's 3. What is it? What's the name? We can see it. So in the common fraction system, the name and the number both are written down. In decimal fraction, we only write down the number. We don't write down the name. And we all know there's a clever way of doing things. We don't even do these headings, right? Normally we don't. Because this is more than enough. You and I know this is called a place value system, often attributed to the Hindu Arabic civilization. Yeah, so people often attribute this place value system to two civilizations, the Islamic and the Hindu civilizations. Yeah, no wonder we call this the Arabic numerals or the Hindu Arabic numerals, right? So yeah, they're exactly the same thing. They're all exactly the same thing. In the Hindu Arabic system, you and I call this decimals. We don't write down the denominator because it's not necessary. In the common fraction system, and this is not Hindu Arabic system, yeah? It's a system where you cannot just say, so in the case of Hindu Arabic system, place value system, you can just write down the numerator and people know what you mean. You can simply write down the numerator and people know what you mean. So all you need is the numerator and people know what you mean. Yeah. But in a common fraction system, you cannot do that. You cannot say, I mean to say 3/7. Nobody will know this is 3/7. You have to write down the name. You got no choice. Yeah. So what is different? Just a system. It's a different system. It's like Urdu and English, two different languages. But you're saying the same thing. So you're actually saying the exact same thing in two different languages. This one, the third one, is not common. Like nobody write 3/10 like that. The one in orange arrow, right? It is not normal for mathematicians to write 3/10 like that. Although it means that. Although it is the easiest one for people to understand, it is not used. Yeah, it's not a standard language. But you have you have this, the brown one, the Hindu Arabic system. You have this, the orange one, not a standard system, and then you have the red one, which is the common. So there's no difference conceptually. Let me illustrate. So when students, you just saw the Barbados, I just came back from Barbados, the place with 200,000 people, right? But they do struggle in getting everyone to know the same thing. So not just the size of the country, actually, apparently. So in decimal numbers, when you do things like this, students will know that, well, it's apples and oranges. I cannot add them up yet. This is 4/10, and that is 3/100. Not the same thing. And then some students will say, well, I know that this is really 40/100, and that is 3/100. 40/100 and 3/100, well, business as usual. 43/100, and 43/100 is written like that. Exactly the same concept. Students will always say to themselves, how many? 2 and 1. Well, are they apples and oranges? Oh, in this case, okay. Both are tens. 2 tens, 1 tens. Business as usual. 3 tens. So when we do what we normally do, we're helping students check if the nouns are the same or not. By doing the vertical method, students can visually see, both are tens. Business as usual. I can add the 2 and 1. If I did the first one, they will say, well, the first one, that's 4/10. The second one, oh, that's really 3/100. So no, I cannot add the 4 and the 3. But thankfully, I kind of know that 4/10 is 40/100. So that's equivalent fraction, really. I know that 4/10 is 40/100. Oh, now business as usual. I can add them up. All right. So thanks for asking that question. The answer is there is no difference.
Yeah.
That means we cannot say 0.4 because 0.4 is not reading it correctly. 0.4 is like saying APPLE. You're making sounds of symbols. 0.4 is spelling, not reading. It is a bit strange when we go to class and say BOYSANDGIRLSGOODMORNING. None of you do that, I'm sure. That's very strange. We don't spell all the time. We read. We say, boys and girls, good morning. Likewise, it's very strange to say 0.4 plus 0.03. That is doing GOODMORNING. Imagine you try to spell. Pick your favorite book, whatever your favorite book is. Merchant of Venice, if you like Shakespeare, or Harry Potter, if you like Harry Potter, or any of your favorite book in any languages. Nobody spell the book. Nobody open the book and go GOODMORNING. Nobody does that. Unfortunately, in mathematics, we overdo this. We do 0.4 plus 0.03. When you say 0.4, the idea that this is 4/10 is not obvious. When you say 0.03, the idea that this is 3/100 is not obvious. The moment you don't say tens and hundreds, the moment you don't say half and thirds, you may not realize that they are different things, apples and oranges. And when you don't realize they are different things, well, many students may find it possible to just add up whatever number they see on the page. Yeah? So I gave you quite a lengthy answer. The short answer is there is no difference at all. Whether it's decimal, fraction, or common fraction, the concepts are the same. Two concepts. Number one, knowing how to read. Knowing how to read a symbol. Number two, knowing what to do when the nouns are different, and that's equivalent fraction. All right? Thanks for that question to allow me to re-emphasize that whatever we discussed today, although I did say fraction, applies to decimal as well. Only two things: know how to read and good at equivalent fraction. Is there another question that someone else would like to bring up?
Okay, I think we can take questions at the end. First, you can finish.
We are actually done with the content. Only two things for fraction. Yeah. So the half an hour is for people to clarify. Anything else that you would like to
Okay.
know? I told you, maths is quite simple.
Yes,
It's
that's
not
great.
overly complicated.
Yes, that was very simple. So let me take questions. Sadia Kamal, have you any question regarding the session? You can ask. Sadia Kamal. Muhammad Nasir Aziz. Muhammad Nasir Aziz. जी मोहम्मद नासिर अजीज साहब, कोई क्वेश्चन है आपका?
So yeah.
How can-
Anything else
Yeah,
anyone
there
wants
is
to bring up?
there is the question in written form that
Yes.
student will understand the concept of equivalent fraction, but they find difficult how to represent equivalent fraction in pictorial form.
Thanks for that question. I'm waiting for that question. Right? So there are only two important ideas. Yeah. And the second important idea is equivalent fraction. The question is, how do we show it pictorially? Yeah. Thanks for that question. So let me demonstrate that. So I think I have established the fact that equivalent fraction is important. Next is, how do we help them learn it in a concrete, pictorial, abstract way? The theory by Jerome Bruner. Yeah. So when I went to school, that's a long time ago, right? Because I'm almost 60 years old. So when I went to school, it wasn't well taught, obviously. But you don't blame the teachers, because back then, they didn't really have good access to professional development. So all the teachers did was to teach us the rules. Yeah. And many people do not really understand the meaning behind it. Yeah. So first, the meaning behind it. So when we do whatever we do, we're actually just asking ourselves, is there another name for the same thing? Is there another name? In mathematics, we call that renaming. Yeah. And renaming is quite common in many parts of mathematics. Yeah, like we say 110 is 10 ones. So that's renaming, isn't it? Changing the name. Renaming is not unusual in our everyday life. 1 dozen, well, that's 12 pieces. Yeah. Or in some countries where we use dollars, $1, well, that's 100 cents. So the process of renaming is changing the name without changing the quantity. Changing the name without changing the quantity. That's essentially what equivalent fraction is. So renaming always gives us something equivalent, equal. Yeah, changing the name without changing the amount, renaming, getting equivalent. In this case, equivalent fraction. So I suppose you can change the name. The convenient ones for us, I suppose. I think 6 is convenient. I suppose 9 is convenience. Some people can try, but I think half is a bit inconvenient. Not sure. Yeah, can we also rename it as ones? Yeah. So this is all what we want to do. Like, yeah, we want to try. So that's basically what renaming is. That's basically what equivalent fraction is. So colleagues, do our students know what are they doing when they do equivalent fraction? I leave the answer to you. Do they know what they are actually doing? Even if they know how to do, many students can do this so quickly. Multiply numerator, multiply denominator. Multiply numerator by 3, multiply denominator by 3. They can do this all correctly, yeah? The question I want to ask you is, do they know what they are doing? Do they know that they are changing the name? Do they know that they're just changing the name? Like, I prefer to call this by a new name. How do we do it pictorially? Let me now do that. So pictorially, we all know. I suppose we can let this be 1. Of course, concrete will just be a piece of paper strip, easily available. And then they will fold. And when they fold, they can check and they can draw. Yeah. And they can draw. They can say, well, that is what a third look like. So they can represent 1/3. 1/3 quite easily, right? So they ask themselves, how can I change a name to, let's say, 9s? But I want to make sure they're still equal. So, colleagues, I'm treating you a bit like student now. Class, can you imagine the third becoming 9s? Can you imagine the third? 3 pieces make 1. Can you imagine the third becoming 9s? What must I do to the third? What must I do to the red piece? What must I do to that in order for me to get 9s? Is that right? I need to cut it into 3 pieces? Are you sure? Are you sure if I cut this into 3 pieces and continue doing that, this piece is going to be a 9th? It's a 9th if 9 of this make 1. Is it true 9 of this make the whole thing? Well, we can try if you're not sure. Oh, I think we are correct. When one becomes 3 pieces, when 1 becomes 3 pieces, thirds become 9s. And the value is still the same. Right? So I have given you both the pictorial representation but also the articulation, the reading. Yeah? Let me do another one with you. When 1 becomes 2, let me do it again. When 1 becomes 2, can you imagine it? When 1 piece becomes 2, maybe I draw it for you. If I let this be 1, and we all know how 1/3 looks like. When 1 piece becomes 2, can you imagine? When 1 piece becomes 2, the name has changed, isn't it? The name has changed from third, I wonder, to what? When 1 becomes 2, if you're not sure, you can use a diagram to help you. When 1 becomes 2, oh, that's right. The thirds has become, we know the name for this? Yeah, the name is, depends on how many make 1. Since 1, 2, 3, 4, 5, 6 make 1, I suspect we know the name. So when 1 becomes 2, that's correct. The thirds has become 6. And the value has not changed, isn't it? That's right. So they are still equal. So when 1 becomes 2, the name changed from thirds to 6. And the value is still equal. When 1 becomes 3, the name changed from thirds to ninths. And the value is still equal. So thanks for asking. This will be the pictorial representation, how we drew pictures for equivalent fraction. But more importantly, the language we use as teachers to make sure they understand conceptually what equivalent fraction is. So equivalent fraction is basically, how to get more pieces. How to get more pieces, but the amount is the same. It is an everyday concept, like you got a cake, right? And you cut your cake into whatever, like this maybe. You cut your cake into 3 big pieces. Question is, can I cut the cake into smaller pieces? Yeah, of course I can. Now I have the cake as 3 pieces, but the name is thirds. But can I cut the cake into more pieces? Yeah, I can. I can cut the cake into 6 pieces. I mean, still the same amount, but the name is different. The name is 6. In fact, I can cut the cake into even more pieces. I can cut the cake into, 12 pieces. But then the name is different. The name is a new name. The name is 12. I can't even spell 12. No problem. We got a symbol for 12. So in mathematics, we all have symbols for words. And that's what we do. 3 thirds, 6 6, 12 12s. And they're all referring to the same amount of things. So do you notice that equivalent fraction is not a difficult concept because it's encountered in their everyday life? I'm sure they have seen, or they have even do it themselves. They have cut a sandwich, they have cut a cake, they have cut a bar of chocolate, they have cut what they need to share with a sibling. All children have experienced making one piece into more pieces, either when they break their chocolate to share, or they cut the cake to help their parents, or when they tear the piece of paper up. Every single child have done equivalent fraction, which is increasing the number of pieces, but overall it's the same thing. That's because each of the piece is increasingly becoming smaller. So no wonder you get 12 pieces. It's 12 small pieces. It's 3 bigger pieces. Right? Stop here for further question. or anything else before we end?
Yes, well explained, and there are a lot of comments on that they understood it very clearly. And actually, we are very new to that CPA, concrete, pictorial, and abstract. So it was very interesting for us. So how we can, but actually we are at, you can say we are at the beginning. We have to start these type of activities in the class. So I think you should have some suggestions that how can we adopt this method.
Yes. I think that will be a good way to conclude today. So, as I mentioned, today is a first session, first time. Of course, it's even better if you're in the same room with me. Then I will model for you how, as a teacher, I will be, running the class. But this is a good start where you're getting some information from me, and hopefully, over time, more conversation among ourselves. So, you can put in the chat, just talk, because this is a class. You go to any class, you talk to your classmates. Have you been to a maths class and the students are all quiet? I always tell my teachers, if you go to a class and it's quiet, it is suspicious. A quiet mathematics class is suspicious. Mathematics is a human activity. We need to talk, we need to chat. You ask any mathematicians, as in professors in mathematics, they almost never work alone. They always have colleagues, they communicate. One very important activity for mathematicians, when I was a professor, I was there for 10 years. A very important activity we look forward to every day is coffee break. Very important to us. Coffee break is part of work, because that's where we talk to colleagues, and that's where we get ideas, that's where we get collaboration, that's where we become better in what we do. Same for students. Yeah. So this is the first session. In the first session, I just want to appeal to you to believe that every single child can learn. In fact, can learn quite well. They may not be doing well now. It doesn't matter. Maybe they are now 10 years old. You help them 1 year, 2 years, they become a bit better. By the time they finish with education system, if every teacher is like you, they will do perfectly all right. They will be able to access further learning. They'll be able to access gainful employment. We know that for a fact. Yeah. From research as well, but even from personal experience, because I've been a teacher for a long time now, many of my students, in fact, all my students whom I taught as children, they are now grown-ups. And we know they all can learn. Never mind how they are now. They can be failing, they can be doing not well. So that's the first thing I want to mention. And the second one today, I want to use fraction as a starting point, because fraction is a difficult idea, just to show you that, well, it's not that complicated. Just two things. Just go back to the same two things. And thanks to your question, I have mentioned Brunner, concrete, pictorial, abstract. In the
That's
next
great.
few sessions, we are going to add on more tools, and you can ask any question you want. I'm able to use your question to deliver the session. Do not feel that questions are interruption. They are not. In fact, questions are so important in any lesson, both for your students, but also in adult learning. All right, I'll stop here.
Okay. Yes, there is one more question, but I think if you can answer in just 1 or 2 minutes, I think time is getting to the end. That if we are going to arrange the fractions from smaller to the larger, so a quick way that how can we draw them in a picture form, that we are arranging the fractions. The students are a little bit confused with the abstract values, that 2 by 3 and 4 by 5, are they greater or the smaller?
I will answer that question in greater detail in a separate session, but a
Okay.
brief answer will be, actually you answered it already using diagrams. When they draw one, yeah, and they represent, they use one, and let's say 1/7, they cut into 7 parts. 1/2, they cut in 2 parts. 1/3, they cut into 3 parts. From there, they can see whatever fraction they want to see. A short answer is still back to Brunner. Use paper, same length paper to represent one, and then let them fold to represent whatever number. There'll be other answers, including the more abstract ones, because they cannot be folding paper all the time. That's also not the intention. The paper is to start them off, especially for the reluctant learners. but there's a way to propel them up to abstraction. I will use one of the future example on that lesson, arranging fraction of different sizes. Yeah, thanks for that question.
Okay. Jamal sir, if you have any question.
Yeah, well, it's been a very informative session, and what you talked about asks for a change in mindset. So, okay, there is maybe some easier ways of making that journey short. So, if you can give some documents, some maybe questions, something is available in written, some lectures or more, then Mr. Safiullah can pass them on to the teachers, and they will go over them in their own good time, because this will need a change in the way of thinking of the teachers first and the students afterwards. So in that, Safiullah, you can coordinate with Dr. Benhar and pass on this literature on to the students and the teachers. And I believe that we have taken the first step in this journey, and I can already see how going along it will help us reach, inshallah, one day where Singapore is now.
Inshallah.
It'll start to activate a part of the brain that so far we have relied more on just formulas and just rote methods. Okay, just apply that formula, take that approach, and come up with answers. That has been the way we have been doing, but this session opens a way out, and this is why we are here.
For sure, inshallah. Yeah. Thank you so much,
Thank you
all.
very much, Dr.
We'll see
Benhar.
you again
This
the
will
following
continue,
week.
and whatever information you can give to us, we will pass it on. And if the teachers have questions, then they already have the email and the number of Mr. Safiullah. And one thing, Mr. Safiullah, I will say that you make a briefer version of this in Urdu and post it out on your YouTube channel, so that what has been taught here or discussed here in English is available to teachers who are more comfortable in Urdu, and also to the students. It really has to be going to the students. So that way the students can become also conversant with it.
Okay, sir, inshallah. Okay.
So thank you very much, everyone. Yeah, I think we'll end here. We'll see you again the next session.
Okay. Thank you
Thank you very much.
Thank you.
Thank you. All the best. Bye-bye.
All the best.